I would like to thank the organizing committee and organizers for giving me such a very good opportunity to be here. Today I'm going to present wormhole model with a hybrid shape function in FRT gravity. Basically, this FRT gravity, which is modified theory of gravity, as we know that general theory of relativity, it has very wide range of applications and all, but still it has some issues for which we need to find the alternate for this gravity theory, and that is that modified theory of gravity, and FRT gravity is one of that modified theory of gravity. So in this model, what we have constructed a wormhole model within the framework of FRT gravity. So let's start. This is the outcome of the topic outlines of my talk today, and yeah. So first of all, if we talk about the expansion of universe, and it was known about since 1929, and after that there are so many cosmological projects like supernova project and supernova system. So after getting confirmation from this observational evidence that universe is expanding and all, and to know this theory expansion of universe, there are two ways we can approach this expansion of universe. We can consider the unknown form of energy known as dark energy, or we can go for the theoretical point of view, that is the alternative theory of gravity, or we can say the modified theory of gravity. So here we have concentrated on modified theories of gravity in order to explain, or in order to understand the expansion of universe. For that purpose, there are several modified theories of gravity. As you can see, FRT gravity, FRG gravity, and FT gravity, and so on. So here we have concentrated on FRT gravity, and which was developed by Harko et al., and which is the most recent generalization of FR gravity, which Lagrangian is constructed by Ricci curvature R and trace of energy momentum tensor T, and that represents the exploring candidate of acceleration of universe. And this is the mathematical formulation of that FRT gravity theory. As you can see, this is the general form of FRT gravity field equation. And then by considering a appropriate matter Lagrangian, we can get the set of field equation, and with the different choices of FRT function, we can get different set of field equations. And in this model, we have considered another solution, which is wormhole solution. So initially, we should know what is this wormhole solutions and all. Basically, this is a hypothetical form. Till now, we don't know its observational things. So in hypothetical, it was it was given coined by, it was given 1980 by Maurice Thron. And the wormholes, we can say these are the two-way tunnels attaching different regions of space-time. And the minimal surface area, as you can see in the figure, which is known as the throat of the wormhole. So what we have to concentrate here, we have to see the properties of the wormhole, and which basically which basically exists, which basically approaches the violation of null energy condition. This is because the exotic presence of exotic matter at the throat of the wormhole. But why we are interested to concentrate this wormhole theory in modified gravity of theory? This is because the modified gravity theory is allows to be the energy condition should be positive and validate. But in case of wormhole theory, it violates only because of the presence of exotic matter. So we have to concentrate to see the amount of exotic matter, or if possible, we can reduce the exotic matter so that we can approach this wormhole theory without existence of this exotic matter. So for that purpose, it will be very interesting to discuss the wormhole solutions or wormhole theory in the framework of modified gravity of theory. So this is the basic properties. As you can say, the wormhole parametric and wormhole properties, it should whatever functions we are considering here, the shape function and redshift function in the geometry of wormhole, that function should satisfy these four properties or 4 conditions, as we can say. So whatever function either we are considering or we are evaluating this function, so we should check these 4 properties it should satisfy, and these 4 properties, which is known as the wormhole metric properties or conditions, we have to take care when you are taking these functions or you are evaluating these solutions as well. So here, this is the model field equation, and we are going to find these solutions. In this model, we have considered the first linear form of f of RT gravity, and the most important part, interesting part for this form is, if we consider the coupling constant lambda is 0, it will immediately reduces to GR. If someone wants to check what is the approach in GR as well as in modified gravity, so this form is very easy to approach in both ways, GR as well as modified theory of gravity. So by considering this first linear form, and then we have to take a energy momentum tensor, and for this model we have taken the energy momentum tensor for an anisotropic fluid and satisfying the matter content which is given in this equation. So by considering this set of field equations along with this matter content, so we have obtained the set of field equations. As you can see, in this set of field equations we have 3 equations and 4 unknowns. So to make it consistent, we need to assume one ad hoc assumptions, and that assumption should be physically reliable. So here, in case of wormhole geometry, as we are looking for wormhole solution, we can take the relation or you can take the assumption from the geometry side, like either shape function or redshift function. So here we have considered the redshift function as a constant. So only we have the choices on shape function, or we can take the matter content rho, PR or PT. But here we have proposed a new shape function to find out the exact wormhole solution within FRT gravity. So from this set of field equations, if you simplify, then we will get the general form of rho, PR and PT. These are the matter contents, and in terms of shape function we have obtained here. So now here we have proposed a new shape function. So we have proposed a new hybrid shape function. Why we are saying it is hybrid? Because it is a mix of power law as well as exponential. So for that purpose, we can name it as a hybrid shape function. As we have discussed before, that shape function, whatever shape function we are considering, that should satisfy the wormhole properties or wormhole conditions. So in order to satisfy the wormhole conditions, as you can see in this graphs, all that 4 conditions are satisfied the proposed shape function. So here the shape function is valid to consider to find the solution of this model. So using this shape function, we have obtained all the energy conditions and the matter contents. Basically we have focused on the density, and we found the density is positive throughout the model, and all that energy conditions, as we can see here, the null energy conditions and the strong energy conditions is violet, which indicates the accelerated expansion of the universe, and the null energy condition, that is the most important condition to consider here, to consider for the discussion of wormhole model, it should be violet. But here in radial coordinate it is validates, only on tangential coordinate it is violates. So the thing is, whole null energy condition is not violating, only it is violating in tangential part, and but radial part it is validating. So after looking for this energy conditions behavior and the density behaviors, now in order to check the equilibrium conditions for stability of this model, so we have considered the TOF equations for checking the stability of this model through the equilibrium conditions. So by using these TOF equations, we have obtained this force: gravitational, hydrostatic and anisotropic force. Since here we have considered the redshift function as constant, so the gravitational force, it will be approaches to 0. And the condition for this equilibrium condition, for equilibrium state, the sum of all the forces, it should be 0. So here we have to check the anisotropic force as well as hydrostatic force, all together it should be 0. As you can see in that graphical view of that function, of this equilibrium conditions, in all the cases, all values are approaching to 0. So in that means we can say the model is satisfying the equilibrium conditions, always the model is stable. So to make another point of view here, we are finding the hydrostatic force is positive and anisotropic force is negative. So to check the nature of geometry, so it defines this figure 3, this one is defines the geometry should be attractive, and to cross check this attractive nature of the geometry, we can consider another dimensional parameter known as anisotropy parameter, and here we found the anisotropy parameter is less than 0 for all positive values of R. So it is confirmed that the attractive nature of geometry of this present model is due to the anisotropic fluid matter. So the attractive nature of the geometry is confirmed through the equilibrium condition as well as the anisotropy parameter. Now to cross check that shape function, if we come to the results and discussion, we have focused a special kind of shape function to construct the Wormhole solution which provides an attractive geometry. And we have started the Wormhole construction by considering an anisotropic fluid with an appropriate choice of shape function. If someone will ask, so what about the isotropic cases? Here we have discussed for isotropic case too. So for isotropic case, isotropy distribution of pressures, the Wormhole solution obtained through the definition of shape function has some interesting behavior. First of all, this is the solution, this is the matter components what we have obtained for the isotropic case. So to discuss the equilibrium conditions, the gravitational and anisotropic force are 0 respectively, and only hydrostatic force is obtained as this one. So here the hydrostatic force is found as negative for the given value of lambda and diverges to 0 as to follow the POV equation. And this nature of hydrostatic force indicates the repulsive geometry. So if we'll consider the equation of state parameter here, in anisotropic case has no role for value of lambda, but in isotropic case the US parameter is coming greater than -1, which is shows the Quinton's phase. So while the phantom phase it is less than -1 occurs at some certain range of lambda. So now if we'll restrict the range of our coupling constant, so what we'll get here, in that range we are getting the equation of state parameter is in Quinton's phase. As we know, the phantom phase will allows the null energy condition violation. So that means if we see here, the derived model in this case avoids the existence of exotic matter. This is because the existence of exotic matter allows the null energy condition violation. But here the matter phase, if you see the phantom phase, it is not supports the phantom phase. So you can say here the existence of exotic matter at the throat by observing the Quinton's phase. It is avoids the existence of exotic matter. That is our motto to say here. In modified gravity, we should concentrate on reducing or avoiding the existence of exotic matter. So for that purpose, that model is quite interesting on this context and all. So for all details, we can see the link of this article and which is published in New Astronomy. So thank you all for listening. Is there any questions? Questions, please.
Thank you, Dr. Parbati. That was a wonderful presentation. So yeah, we'll see if anyone have any questions. Yeah, we can see in chat. If you can see in the chat, we can answer directly, or I will read for you. So how does the shape or the WH geometry in attractive or repulsive forces?
Okay.
What is the exotic equation of state of your exotic matter?
Yeah, how does the shape function shape the wormhole geometry in attractive and repulsive force? Yeah, that anisotropy parameter, as we can see here, if it is less than, we can say, and if it is greater than, that's we can say through that it is attractive or repulsive. But if you talk about the shape function, how it is shapes the wormhole as attractive and repulsive, that things we can focus on the throat of the wormhole. In that throat of wormhole, if we have the exotic matter that is violating the non-energy conditions, but the attractive repulsive force that it is at the throat of the wormhole, and which is defined by the shape function.
No,
Am I
thank
audible?
you. Yes, 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 Mr. Pralay.
Okay, okay. Can
Yes,
you please go to your slide?
yes,
Go to that slide. Shaping.
yes.
Yes. Then this.
In this slide, sir.
No, that attractiveness and repulsiveness.
Sorry, I'm not audible,
No,
sir.
we cannot hear you now.
No, no. How the shape function shapes that slide? Sorry, without that is attractive or repulsive.
Here. Sorry, sir, I could not get you.
Am I audible? Yes or no?
Yeah,
Yes, you
now it
are
is
audible.
audible.
Yes, yes. So how you are applying the shape function to characterize the geometry, either attractive form
Yes,
or
yes.
repulsive? Yeah. That I want to understand that illustratively from your figure.
We are not using that shape function to make it is repulsive or attractive. We are using that shape function to get the solution, to get the matter components. After that, we are calculating that force.
Can you get in the equational state?
The thing is, we have, yes, sir, we have different kind of wormholes. For in case of traversability of wormhole, we can consider to shape function or redshift function. To avoid the flatness issue, we have considered here the shape redshift function as constant. So we have taken that shape function. Using that shape function, whatever the things we have calculated, as per that nature of the force, we can say it is attractive or repulsive. That's things what we did here.
Okay, okay. Thanks. Thank you.